So in this video we'll be talking about two problems. So these are the two code chunks that are given to you, and you need to find the time complexity of both of them. So let's first start with the first one. Pause the video and think about the time complexity of the first one. It's pretty straightforward, but still, I'm assuming that you have thought about it on your own. So if you think about it, I into I less than equal to n, right? So I square is less than equal to n, so I is less than equal to root n, right? So it's just looping from 0 to root n, and for every loop it's doing order 1 work. So this would be order root n complexity loop, right? Like this part of code would be order root n, right? Let's move to the next one. So this is the second one. Pause the video and think about this code as well. Like what would be the complexity for this be? Okay, so I'm assuming that you have thought about the time complexity of this. This is not as straightforward as this one because the internal loop is depending on the external loop. So now one way to generalize such problems where the internal loop is working on the external loop is like you write the total time of this in terms of I, okay? So if there is a particular I, the time complexity of this is order I, right? Because whatever the I is, it loops from 1 to I, right? Order I. Now this part is done. Now this is same as this, but now there is some internal work that depends upon I. So when I is equal to 1, the internal loop is order 1. When I is equal to 2, you have order 2 plus order 3, so on, up to what is the last I that you can see in this state? Order root n, right? Because that's the maximum I where you can go up to. Beyond that, everything becomes like greater than root n, so that's not possible. So these are the sum of all the I or order I number of iterations that happens in this internal loop. And if you think about this is nothing but the summation. Like if you just collapse it up into order 1 plus 2 plus dot 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 up to plus root n, and this will be nothing but equal to order root n into root n plus 1 by 2, right? And this by 2 is like a half, that doesn't matter, and this is equal to, so this root n is n and plus root n, right? But root n is smaller than n, so this is order n. Okay, so the time complexity of this loop structure over here is order n. Okay, so that's all for this video. See you in the next one.